Right, so we're on Unit 7, and this is actually Goal 1. And we're looking at variation functions. This unit's on rational equations or expressions, well, equations. But we're going to start with variations because they're a form of rational equations, but they're not solving rationals like we'll get to. So we have different types of variations. So how things affect each other are your variations. You have direct variation, you have joint variation, and inverse and combined. And what we see in every variation is a constant of variation. So we have a steady, it's when one changes, the other thing changes, but there's a constant that's making them change at that same rate. So we're going to look at direct variation, and there's a few ways that you can do these. We're going to stick with finding the constant k. So a direct variation means it's directly affected when x changes, y changes, x changes, y changes. And you can see that this is a linear, and k is your constant of variation. So that's always going to stay the same in whatever situation. So if our economy goes up, or if our jobs increase, then our economy increases. So we see that those directly relate to each other. What's that? How much change does that make? That would be your constant. You can also look at these as proportions because since they are directly changing and affecting each other, they're also proportional. So you can do these like a few different ways. So we know y varies directly. When we know that, you should think multiplication. So you know it varies directly with x. So y varies directly with x. Then you can plug in to find your constant. When y was negative 15, x is 5, so you're going to plug in the one that gives us both the variables to find your constant. So we have this situation that changes all the time the same, and we know when x was 5, y was negative 15. So we'll find our constant of variation. So k equals negative 3. So we know this is our equation for this situation of y and x. And then we can use that to find either y or x given one or the other. In this case, we're given x and we're finding y. So y equals negative 3 times 3, or y equals negative 9. Because they wanted us to find y when x equals 3. So direct variation should have you thinking multiplication on there. We're going to go ahead and go past that and go to joint variation. So in joint variations, it's just like the direct variation, except for you have two things that are affected. So two things are changing when y changes. So y varies jointly with x and z here, because those are the ones. So we have our constant of variation still, and it varies jointly with x and z. So anytime I see an equation that looks like this, where I have two variables changing with a constant, this would be an example of a joint variation problem, and this would be my constant of variation. You can also set that again, since it varies jointly, it's also directly, and you can set that up as a proportion if that is easier for you. So we want to find y when x is 10 and 5. So this is what we're looking for. So we're not going to use this one yet because we want to find our constant of variation. And you can only do that when you know how everything was affected. So when y varies jointly, so we know with x and z. So when y was 12, x was 3, and 8, z was 8. So that gives me how I can find my constant of variation. Divide by 38. Or 38. Goodness. 24. And k equals 1/2. So I have this situation is represented by this problem. So now we can find any variable x, y, or z, and it wants me to find y when x is 10 and z is 5. So what does y equal when x is 10 and z is 5? So we have 50 times 1/2, so y equals 25. So that's joint variation. Next, we're going to look at inverse. So if direct is multiplication, inverse is opposite. So when we see that first inversely, we should think division. So it's y equals k over x, because y varies inversely as x. So this is a rational equation. So if we were looking at the proportion, notice it's a little bit different, because instead of the r over t, the first r over the first t, it's r over the second t, and so forth. Also, you can look at it like this, that when I multiply these two, that gives me my constant of variation. So r varies inversely as t, so r equals k over t, because it's inversely as t. So when r was -6, t was 2, so we'll find that constant by solving for k, that constant of variation. So k equals -12, so we know in this situation we have -12 over whatever t is. And they want to know what r is if t is -7. So r equals 12 over 7, or you can find your decimal. So combined, we don't have an example of that, but combined uses both direct and inverse. So if it said something was both directly and inversely affected, you would divide the one that's inversely and multiply by the one that's direct. Right, thank you.